These are the notes for section 1.3. So one of the first things, there's kind of two key vocabulary words to go through this, and that is midpoint and segment bisector. So in the past, when I've asked students what midpoint means, they usually think of the middle. And segment bisector is it cuts a segment in half. So if we think about this over here, so if we have a segment, the midpoint is the point that actually divides a segment into two congruent parts. So before, when we were just given a segment like this, it's really easy to say, here are these two segments. So M is the midpoint of the segment. So segment AM and segment MB are congruent, therefore they have the same length. When we were doing the ones that were horizontal and vertical last week, most of you were able to find those. Today we're just going to start getting those at angles. And then segment bisector, although it does cut a segment in half, it could be cut in half by a point. So we could have a segment and it just has a point, just like here. It could have a ray coming out of it. It could have a line. It could have a line segment. Or we could even have a plane, except for we don't do those very often. Okay? And it's the same principle. It cuts it in half. It's just not, it's at its midpoint, but it is sometimes more than just a point when you divide a segment in two. So the segment bisector means you're dividing it by something other than a point typically. So when you start getting these, when they're horizontal and vertical, we found those last week. When you start getting them at an angle, they're a little harder. We can't just find the difference of the absolute value of the x's or the y's. So to find the middle, we actually need to find the middle point. So to find the midpoint, if A is at a coordinate and B is at a coordinate, then the midpoint is when we find the middle of the two x values. So we have to add those together and divide by 2. And the y coordinate is when we take our y coordinates of our endpoints and we add them together and divide by 2. So the midpoint formula is anytime you're given two endpoints, this time we're just calling them A and B. Our midpoint is when we find the average of our two x's. So since there's 2 points, we divide by 2, and the average of our two y's. So we take our y values and divide by 2. The other formula that we're going to get into is distance. So here again, we were able to find the distance when it was horizontal or vertical really easy. When you start making it at an angle, we actually have to find the difference of our x's, just like we did the other day, and our difference of our y's, but now we have to put them together. So distance formula is when you take the square root of the difference of your x's squared plus the difference of your y's squared. Okay. Now I'm going to show you some examples of each of these. And I'll even point out some places where you could pause the video and go on to Big Ideas Math and do a certain amount of problems, save them, and then come back and watch the next part of the video so that you're not watching the whole thing. Or you can watch all the examples and then go out and do the problems. It's completely up to you, but in this video, I will point out some places where you could pause, go do a few problems, and then come back so you're not quite overwhelmed. It breaks it down a little bit more. So some examples. Sometimes we're just going to ask you to identify things. So on examples 1, 2, and 3, we want you to identify the segment bisector and then find the length of AB. So remember, when there isn't a line above here, we're finding the length of it or the distance from point A to B. So in this case, if I want to identify the segment bisector, in this point, the segment bisector is just point M. So remember, if the segment bisector, if it cuts this in half, so if this segment is 13, this segment is 13. So if I wanted to find from A to B, I could add those together. So the length of AB would be 26. So on this one, the segment bisector is the ray MC. And here again, if AM is 8, then MB is 8. So the length of AB would be those added together, which is 16. And for 3, the segment bisector in this case is line L. So if MB is 26, then AM has to be 26. So the length of AB would be 52 when we add those together. This takes it just a step further. So rather than just having numbers, we're going to add expressions. So here again, they want you to identify the segment bisector of segment EF and then find the length of EF. So segment bisector identifying is the same. So we have ray MT. So if we know that this is our segment bisector, M becomes our midpoint. So that means EM is equal to MF. So 6x has to equal 2x plus 4. So we can solve for x. So we're going to subtract 2 and then divide by 4. So we find out x equals 1. Then we're going to have to substitute this in. I'm going to go ahead and substitute it into both sides to make sure I actually solve this right. So 6 times 1 would be 6. 2 times 1 is 2, plus 4 is 6. So we know that the length of EF is when we add those together. So it is 12. Here again, if we identify the segment bisector, that would be line M. So that means that segment EM is equal to segment MF. So x plus 15 has to equal 7x minus 3. So we're going to solve for x. So I'm going to subtract x from both sides. Then I'm going to add 3 to both sides. So I can divide by 6. So I find out that x equals 3. And then here again, I need to substitute it back in. So 3 plus 15, so that means this is going to be 18. 7 times 3 is 21, minus 3 is 18. So I know the length of EF will be 36. And last one, so our segment bisector is point M. So EM is equal to segment MF. So 3x minus 4 is equal to 5x minus 12. So if I subtract 3x using my properties of equality, and then add 12, so I move my constants to the left, I get 8 equals 2x. So if I divide by 2, I find out that x equals 4. And here again, I need to substitute it in. So 3 times 4 is 12, minus 4 is 8. 5 times 4 is 20, minus 12 is 8. So the length of EF would be 16. At this point, if you wanted to pause, you could go on to the 1.3 practice on Big Ideas Math, and you could complete exercises 1 through 9. If you're ready to move on, the next part is actually taking this to the coordinate plane. So one of these, this first one, I'm going to graph so you can see what this looks like. So if I were to actually plot the points, I could plot the point P at -4, 3. And Q would be at 0, 5. So if I wanted to find the midpoint of this, really what I'm having to do is find what would be halfway between 0 and -4, and then what would be halfway between 3 and 5. So some of you would like to graph this and you could find the midpoint, which is perfectly fine if you like to graph. If you don't like to graph, you can use the midpoint formula. So remember I showed you this on the first page. So anytime you have 2 endpoints to find the midpoint, you find the average of the x's, divide by 2, the average of the y's, so you add them together and divide by 2. So to find my midpoint, I would take -4 plus 0 divided by 2, 3 plus 5 divided by 2. I'm going to show you every step. Some of you might do some of these steps in your head, and that's okay. So my midpoint would be at -4 divided by 2. So my x value is going to end up at -2. My y value, I would get 8 divided by 2, which is at 4. And we could always double check that. So if we're looking at our graph, that is exactly where our midpoint ended up. Okay. These other ones, I'm just going to show you using the formula, but you can always double check it by a graph. So here are my endpoints. So my midpoint is going to be when I average my x's, so -2 plus 10 divided by 2, 7 plus a -3 divided by 2. So I'm going to get 8 divided by 2. So my x value is going to end up at 4, which if you think about it, that is halfway between -2 and 10. And 7 plus a -3 would be 4 divided by 2. So I end up at 2. And if you think about it, same thing here, halfway between 7 and -3 is 2. And one more. So 3 plus 9 divided by 2, -15 plus -3 divided by 2. So I get 12 divided by 2. So my midpoint x value is at 6. And -18 divided by 2 is at -9. Well, they always end up with an integer most of the time, but not always. Occasionally you will get a decimal answer. And same thing here, if you wanted to pause the video, you could go complete exercises 15, 17, and 18 now, and they're going to correspond with these. This next part is going to take this a step further. So on these, we were giving you the 2 endpoints and asking you to find the midpoint. These next ones are going to say, well, what happens if I give you one endpoint and the midpoint? How do we find the other endpoint? So on this first one here, again, I'm going to graph it so you can kind of see what it looks like. So on this one, they're giving us the endpoint of J, and it is at 7, 2. And my midpoint, so halfway to the other point, is at 1, -2. So I need to figure out where would my other endpoint. So we know it's going to be down here somewhere, but where exactly is it? So remember, if we had 2 endpoints, we would add those together and divide by 2 to give this. So anytime we have an endpoint and a midpoint, we can still use that basic formula that we did earlier. We're just going to actually separate into 2 different equations. So I know some x value plus the x value of my other endpoint divided by 2 has to give me the x value of my midpoint, which in this case we know is 1. And then we can do the same thing for y. So this some y value plus my endpoint y value divided by 2 has to give me my y coordinate of my midpoint. So if you think about solving each of these equations separately, that will give us our x and y coordinate of our other endpoint. So if you notice on all these, if I were just solving this like a normal equation, so to get x by itself, if I'm dividing it by 2, I have to multiply both sides by 2 to get that to cancel. And then I can solve for x, so I can subtract. So I know my other x coordinate is going to be at -5. So in this case, we're looking for point K, so it's going to be at -5 something. And then we're going to do the same thing over here with y. So if I'm dividing by 2, I need to multiply by 2 to get that to cancel. So y plus 2 is equal to -4. So if I subtract 2, I get y equals -6. That is my other endpoint. So if we go back to what the graph looks like, and we graph this point, so -5, -6 is where our other endpoint should be. And if we graph that, that looks like M is now halfway between K and J. So let's do at least one more of these. So here we go. We have our endpoint and we have a midpoint. So I know that x plus 5 divided by 2 is going to give me the x coordinate of my midpoint. And then y plus -2 divided by 2 is going to give me my y coordinate of my midpoint. So here again, the steps are always the same. We're going to multiply both sides by 2, and then we're going to add or subtract whatever is with our x and y. So x plus 5 is equal to 0. So we find our x coordinate is -5. We do the same thing with y. We'll multiply by 2. So y minus 2 is equal to -2. So if I add 2, I find out my y coordinate is at 0. So K is going to be at -5, 0. So here again, if you wanted to pause the video and go back on Big Ideas Math, that should help you do exercises 19, 20, and 21. And then the last thing that I talked about on that front page was being able to find the distance between 2 points. So I'm going to graph this one again. So if we do the distance from 5, 6 to 1, 3, okay, I could find the midpoint really easily, but distance is, I want to know how long is that segment. So remember the other day when we were having segments that were horizontal or vertical, well, those were really easy because we could easily find, if it was horizontal, we could find the difference between -5 and -3 and find the difference of those. Or same thing, if we had a vertical line, we could easily find the distance, okay? So when you do one that is at an angle, we have to find the difference of our x values and the difference of our y values and find out how long it is. So remember our distance formula is if we take the square root of the difference of our x's squared plus the difference of our y's squared. So in this case, and it doesn't really matter which point is your first point and your second point, I typically just go in order and use this as my second coordinate and this is my first coordinate when I'm filling them in. Just it tends to make it easier for me, but you can do it in whatever order you want to. So I'm going to find the difference of this. So I'm going to find 5 minus 1 squared. So the difference of my x's squared plus the difference of my y's squared. And a lot of the things that people forget is that you have to find the square root of this to find the difference of those since you're combining your x and your y's. And I always advise students, although you could do this whole thing in your calculator, to go ahead and step it out. So we need to do what's inside the parentheses. So 5 minus 1. So we have to take 4 squared. 6 minus 3 would be 3 squared. So 4 squared will give us 16. 3 squared will be 9. So I need to find the square root of 25. So some of these will ask you for an exact answer. So if you can actually use the calculator, and I'll try to get this so you can see it on there, and do the square root. So some calculators have it as an actual button. This one I have to use the second key and then find the square root key, which is above the squared key. And I have to find the square root of 25. Most of you probably already know that's 5. So some of them will become nice numbers. So this is an exact answer. Other ones, like the next one, might not be a nice whole number like this. So let's go through one of these. So here again, I'm going to take and find the difference, the square root of the difference of my x's. So 2 minus 4 squared plus the difference of my y, so 5 minus -1 squared. So 2 minus 4 would be -2 squared. 5 minus a -1, that's like adding, so I'm going to get 6 squared. Notice I'm leaving the parentheses around here because if you were trying to do this, if you didn't have this in parentheses and just took -2 squared in your calculator like this, you're actually going to get a negative answer. That is different than when you're taking -2 squared, which is 4, and then 6 squared, which is 36. Okay, so if I put this into my calculator and find out the square root of 40, I'm going to get a decimal answer. So if they ask you for an approximate answer, you could put in this and just watch how you round. If they want an exact answer, like I think it will ask on your assignments, you'll have to do this. But like I said, if they want an approximate answer, you can enter the decimals. So if I wanted to do this to the nearest 10th, then this would be about 6.3. So be careful when they ask you for an exact versus an approximate answer. Usually the ones when you're first learning this will ask for an exact. When you get into some of the word problems, they might be having you find like the length of how long you throw things, and an approximate answer will be just fine. Okay. So these should help you finish up what's left of 1.3. When you get done with that assignment, make sure that you take a picture of your work and upload it into Canvas for that assignment. And the thing that's going to come after this is a quiz over 1.1 through 1.3. So my suggestion is to go back and review what 1.1 through 1.3 is. If you're in group A, we'll review and you can take your quiz before you leave class tomorrow if you want to. If you are in group B, if you want to do 1.3, what we can do at the beginning of class on Friday is we can review and have you take your quiz. If you want a little bit review with me, if you think you're ready, you can go ahead and take the quiz on Canvas if you think so.